Myself, Saurabh Noskor, Assistant Professor of Garki Memorial Institute of Technology. In my previous lecture, I discussed about electrochemistry. Today, I will discuss thermodynamics. Thermodynamics implies flow of heat. Here, we will study flow of heat. Here, we have to learn some basic term of thermodynamics. First one is system. The part of the universe under observation is called system, and the part of the universe not under observation will be called surrounding. See, this page is my system, and all the things outside this page will be surrounding. Now there are three types of system: open system, closed system, and isolated system. In open system, system can exchange both mass and energy with the surrounding. And in closed system, here system can exchange only energy with the surrounding. And in isolated system, system cannot exchange neither mass nor energy with the surrounding. A perfect example of open system is living system, and an example of isolated system is universe. Now, properties of system. There are two properties. First one is extensive properties, second one is intensive properties. Such properties which depends on the mass or the total number of particles in the system. Examples are mass, volume, internal energy, enthalpy, entropy, Gibbs free energy. I will discuss all the terms in the later video. And intensive properties means properties which does not depend on the mass or the total number of particles in the system. Examples are pressure, temperature, concentration, viscosity, and density. So, mass dependent properties are extensive properties, and mass independent properties are intensive properties. Now we have to learn internal energy. This is denoted by U. The energy possessed by a system by virtue of its existence is known as its internal energy. It is an extensive property and state function. And change in internal energy is equal to heat at constant volume. This is Q means heat at constant volume. And enthalpy is denoted by H. Enthalpy is the measure of the total energy of the system. In case of gas, the product of pressure and volume is expressed as energy. So, the sum of two energy terms, that is internal energy U and PV energy, is known as enthalpy. So, enthalpy means sum of internal energy plus PV energy. It is also an extensive property and state function, and change in enthalpy is equal to heat at constant pressure. So, del H is equal to heat at constant pressure, and del U is equal to heat at constant volume. Now, relation between del H and del U. Also, QP and QV. See, del H means QP and del U means QV. So, these two will be same. We all know H is equal to U plus PV. So, for state 1, we can write H1 is equal to U1 plus P1 V1. And for state 2, we can write H2 is equal to U2 plus P2 V2. Let's say this is initial state and this is final state. So, when we subtract this initial state from final state, then we can write H2 minus H1 is equal to U2 minus U1 plus P2 V2 minus P1 V1. And this is your change in enthalpy. When final minus initial means change in enthalpy. Here also U2 minus U1 means del U, and here will be del PV. And we all know for ideal gas equation, PV is equal to nRT. So, in place of PV, we can replace by nRT. And for gaseous reaction, we can write Ng. Here, del Ng means total gaseous mole of product minus total gaseous mole of reactant. See this example. Here H2 is reacting with iodine and giving Hi. So we will calculate del Ng here. Del Ng means total gaseous mole of product. This is product, mole is 2, so we will put 2 here, minus total gaseous mole of reactant. Reactant are this one 1 mole and 1 mole, so 1 plus 1 2, we will put 2 here, so 2 minus 2 will be 0. So del Ng is 0 means this term will be 0, so we can write del H is equal to del U, this one. Now what is state function and what is path function? Function which depend on the initial and final state of the system and not on the path followed, that will be called state function. This H means enthalpy, internal energy, entropy, Gibbs free energy, change in enthalpy, these all are state function. And path function means the function which depend on the path followed while changing from one state to other. So state function will depend on only initial and final state. It does not depend on the path followed. You may go in this way or in this way or in this way. So state function only depend on initial and final state, and path function will depend on how you go. So means depend on path. Okay. There are several kinds of thermodynamic process. First one is isothermal process. Iso means same. Thermal means temperature. So temperature will be constant here. Temperature will be constant means change in temperature will be 0, and this internal energy depends on temperature. So del T 0 means del U also be 0. This is internal energy. And in adiabatic process, heat remain constant. In isochoric process means volume should be constant, so change in volume will be 0. And isobaric process means pressure will be constant, so change in pressure will be 0. Now we will learn first law of thermodynamics. Different scientists gave different statements. All the statements are identical in significance. All signify basically that energy can neither be created nor destroyed, but can be converted from one form to another form. Thus, first law is actually the law of conservation of energy. And mathematically, we can write first law as Q is equal to del U plus W. Here, Q is heat absorbed by the system, W is work done by the system, and del U is change in internal energy. We can also write differential form of first law. In differential form, there will be dq, here will be du, and here will be dw. In my next lecture, I will discuss about reversible process and irreversible process, heat capacity, limitation of first law of thermodynamics and second law of thermodynamics. Thank you.